Hi, I'm Ms. Blue and I'm going to show you how to divide polynomials with remainders. But before we learn about remainders, we learned how to divide where everything worked out perfectly. For instance, I have 8 pieces of chocolate and 4 members of my family. So if I want to divide 8 by 4, everybody gets exactly 2 pieces of chocolate. There's no remainder, no fighting. But what if I had 15 pieces of chocolate? I still have 4 people in my family. So if everybody gets, let's see, 4 pieces of chocolate, there's still 2 left over. So then I would have to divide each of these 2 pieces into 4 pieces and split them among here. There's a remainder. So this 2 is going to end up getting divided into the 4 spots. The idea is going to be similar when we divide with polynomials. So here's the one that we're going to do together. X to the 4th plus 5x to the 3rd minus 11x squared minus 25x plus 29, all divided by x plus 6. Remember, it's going to be the same as division at first, and then we're going to see how it's different when there's a remainder. So let's first think about this as a multiplication problem, right? So we know that if we multiply the quotients by x plus 6, we would get back to this long polynomial. So let's set up an area model in reverse. Let's try to figure out what do we need to multiply x plus 6 by in order to get back to here. Well, if I have x to the 4th, I know that that means I must be multiplying by x to the 3rd, because x times x times x times x is x to the 4th. And then I fill this one out also using multiplication. Since I have 6x to the 3rds, but I know I want 5x to the 3rds, I know that if I just subtract off an x to the 3rd, I'll met my criteria. So then I think about what I need to multiply here. That would be a negative x squared. That would make this negative 6x squared. And I keep going just like I've done division all along. So if I have negative 6x squared, but I want negative 11x squared, I know I need another negative 5x squared. So that must mean this is a negative 5x, which would make a negative 30x. Negative 30x plus 5x is what would get me to negative 25. So this must be a 5, and this must be a 30. But now that I've met all of these conditions, I end up with 30, not 29. Well, how do I get from 30 to 29? Subtract 1. So this is like the remainder. This is what I need to take away from this last number in order to get back to what I'm trying to get. So our solution is still all of this, x to the 3rd minus x squared minus 5x plus 5. And then I put this minus 1 over x plus 6, and that's what the remainder part looks like. So remember, just like in the chocolate where we had those 2 leftover pieces and we had to divide it by 4, we would put 2 over 4. We're just taking this number and always putting it over whatever it is that we're dividing by. So last, I just want to make sure that my answer is correct. I don't want to be teaching you the wrong stuff. No, I want to stay on this page. So I've gone ahead and typed in the original division problem, x to the 4th plus 5x to the 3rd, yada, 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 divided by x plus 6. I want to make sure that my answer on my whiteboard is the same. So x to the 3rd minus x squared minus 5x plus 5. You're going to need to tell that the graphs are looking really similar. So now let's add the remainder, minus 1 over x plus 6. And sure enough, the graphs are equivalent. So I know that my original division problem is in fact equal to the quotient that I got. And that's how you divide with remainders.